All right. Hello. Welcome to Math 361B. Due to snow and travel, we cannot talk about the syllabus in person. I'd like to really get started on Wednesday. So we're going to record the syllabus, and I'm going to explain everything that I can, and then you can watch this video and we can get started on Wednesday. So first thing in the syllabus, all the boring stuff. You know when the class is, you know where the class is. One thing to really pay attention to though are my office hours. Please make sure you know where my office is and when my office hours are. If none of these office hours work for you, let me know and then we can make an appointment and we can change some stuff around, okay? All right, so next, make sure you have the textbook. It's going to be a really good reference book to learn about Python when you forget certain things that you need to do to get Python to do what you want it to do. Then the book will certainly help. Next bit is what in the world is this class really about? And I asked you this in the survey, and I got some interesting answers, some generic answers. So I want to try and fill that in. The main objective that I have for you coming out of this class is that you are able to write code to do a job. This is an unbelievably important skill that employers are always asking for. Employers really, really want people who know how to code. Doesn't matter what the job is. Even if they're hiring mathematicians, in fact, especially if they're hiring mathematicians, they want you to be able to think, they want you to be able to understand the mathematics, they love you for all your problem-solving skills, but they also really, really want you to be able to code, because coding solves so many problems and solves them so much quicker than you can solve them on your own. And so what we're going to do in this class is really a lot of just writing short pieces of code. And I want you to become very familiar with that and to be able to take a blank screen and turn it into a program that can solve your small little problem that you're looking at. This is really useful even in the pure areas of mathematics, such as number theory or abstract algebra or real analysis. When you're trying to come up with theorems or prove theorems, working examples is really, really important. You always work examples. And so a program will help you work those examples even faster. When you have conjectured a theorem, you think something is true, but you're not entirely sure, well, what you can do is you can test it using some code to see, does this actually hold up, or am I missing something? We're going to see a lot of different examples in which a program can really help us solve lots of different mathematical problems. We're going to be looking at very small problems in this class. This is really kind of what I want you to be able to do, is to write small programs that will solve small, tiny little problems. But this is also a first step towards being able to write large pieces of code like you'll write at Dahlgren or the Naval Research Labs or the NSA. But for these small programs and small problems, there's sort of a different way of writing. And we're going to talk a lot about how coding is different when you're looking at very small problems, really you're the only person who cares about them, and short pieces of code. The way this class is going to be structured is first we're going to talk about just how do you program in general. I assume no programming knowledge before this class. So we're going to learn the basics of programming, which is really nothing more than just learning how do you talk to your computer? How do you tell your computer to do X, Y, and Z? And then once you learn how to talk to the computer, then it's a matter of figuring out, okay, how do I turn this idea I have in my head into a program, into something the computer will understand? And it really is sort of two separate ideas there. And so the next bit of the course is just going to be solving lots and lots of problems. I'm going to give you lots of problems. You're going to figure out kind of how would I solve this in my head? What is the best way to go about trying to solve this if I were to do it on a piece of paper? And then, okay, how can I take that idea and translate it into something the computer can understand? So that's going to be the gist of the course. The assignments in this class are going to be called problems. Kind of fits with the title of the course. Each problem is going to have a list of deliverables, things I want you to turn in. One of those things is always going to be a piece of code. The other one is probably going to be some sort of a write-up for most problems that analyzes the results of the code, analyzes the problem, and tries to answer the problem, actually writes up a solution to the problem in some form or fashion, answers some questions possibly, that explains how was your code useful and what did it tell you. So each problem, each assignment is going to be worth either 2, 5, or 10 points, just depending on the complexity of the problem. Pardon me. We're going to be using Python in this class. For math language, or for math problems, MATLAB is a great language to use. It's really great for beginners. It has one enormous downside, which is the cost. It would only cost you about $100 because you're students. It would cost the university considerably more money, but what I think is much more important is that if you go get a job at a company that does not have infinite resources, it will cost them a lot of money, thousands of dollars per user for MATLAB. MATLAB is very expensive. Python is free, and it does basically everything that MATLAB does. So if you can learn Python, if you can work with Python, that puts you one step above the person who can work with MATLAB. And also, if you can work with Python, you can work with MATLAB, you can work with C, you can work with Java, you can work with any other language. They're all very similar to each other. The way that we are going to turn in assignments is using a version control system called GitHub. I'm going to talk a lot more about this somewhere else, so don't worry too much about it right now. But just know that the way we're going to turn in homework, your assignments, is not through email. It's not through turning it in class. You're going to be uploading it to a cloud, essentially. But we'll talk a lot more about that. GitHub, in general, is a good skill to have. And when you write up your assignments, when you write up the analysis of the problem, you're going to do it in LaTeX. You're not going to do it in Word. You're not going to write it up in paper. You're going to write it up using LaTeX. Those of you that have had me for 330, you already know all about LaTeX. If you have not used LaTeX before, don't worry. I'll go over it in class. It is a typesetting program that's used to essentially type up mathematics. It is very popular and a skill you really need to have. All right. The final for this class is just going to be another problem, but it's going to be a big problem, and everyone's going to do their own separate problem. You're going to get to choose it yourself. I'll give you a list of problems to pick from. You can pick a problem that really sounds interesting to you. If you come up with something not on that list, but it sounds interesting to you, that is fine. But all your problems have to be approved by me. So you'll take the problem to me and say, Dr. Collins, I think this looks like fun. I think I can do something with it. If I think it is complex enough and interesting enough, then I say go for it, and you can have some fun. All right. So in class, there's going to be lecture. I'm certainly going to, at the beginning, talk about how do we program. I'll introduce new areas of mathematics that are related to each of the problems we look at. But there's also going to be a lot of group time where you're going to work in groups of mostly 3, but some 4, and really solve the problem and work on these problems together in groups. And so to facilitate that group work, there are 3 different roles that members in the group are going to have. And we're going to switch off these roles every day. We'll change up the groups periodically throughout the semester. The first role is programmer. For each group, each day, only one person is going to be allowed to write code. This gives everyone an opportunity to really write code. No one skips out and doesn't do anything code-wise in class. And so what you're going to do is hook up your computer to the big screen, and the entire group can work on, okay, what do we do? How do we do it? One person is going to actually do it, actually write the code in class. Another person is going to be the writer. This one's going to be a recorder, sort of takes notes, write down the results of the code, keeps track of all the information and the analysis that's happening. And finally, we're going to have a facilitator and sort of a spokesperson. This one's going to keep everyone on track. This is the one that makes sure that the group is continuing to make progress throughout the class period. If you get stuck, this person figures out how to get unstuck or calls me over and says, Dr. Collins, we're stuck. And also, when we get together and each of the groups start sharing, hey, this is what we did, and these are some of the results we came up with, this facilitator, spokesperson, representative is going to be the one that actually shares those results. All right, so there's some ground rules for this class. The main one is all the code you write must be your own original thoughts and original work. All the problems that you're going to get in this class have been solved. I'm almost certain they have been solved before, and code has been written to solve those problems, and you can find it online. All right, so I'm just getting that out there right now. You can completely cheat in this class, but we have an honor code. Everyone here has agreed to abide by the honor code, and I'm not really that worried about it. But I want to write this out and make it very clear. You can go online to figure out particular syntax for Python or a mathematical definition. Do not go online looking for how do I solve this problem with code. That's what this class is all about. You are meant to try and figure out how to write code to solve each of these particular problems. So all your code has to be your own ideas written down. From my survey, it looks like everyone has a laptop. And so what I want you to do is bring your laptop to class every single day. It's going to be useful. You're going to be writing code. So everyone, just please make sure to bring your laptop every day. You're definitely going to need it at the beginning of class when we start installing Python, installing GitHub, getting some of these programs on your computers. Your grade for this class is entirely based off of problems. 85% is going to be the problems that we do each of these assignments during the semester. 15% is going to be the final problem, this big problem that you do at the end. We have our letter grade distribution, and that's pretty much everything there is to talk about. I hope you guys are excited for this class. I know you're going to learn some very useful skills no matter what you plan on doing when you get out of here. You want to work at Dahlgren. Dahlgren has been begging us to teach a programming course like this. If you want to go on and get a PhD, this is incredibly useful for higher level mathematics. If you want to teach in high school, your students really need to know how to program. The world is just moving to a point where almost every position would benefit from programming experience. So I look forward to seeing everybody on Wednesday, and enjoy your weekend.